Hello everyone, Konstantin is here, and today's topic is web integration or building distributed systems using ONCE Enterprise, which means that in ONCE Enterprise you have all the features necessary for you to implement some public API and give other people access to your API so they can retrieve some data from your system, or maybe put some data into a system, and on the other hand you can connect to third-party APIs and do the same, retrieve their data or post something to their databases. And the first part of this picture is web services. So what is a web service? A web service basically is just a public API working over HTTP protocol. And HTTP, of course, stands for Hypertext Transfer Protocol, where the most important keyword is text. So it means that you can't transfer texts only and nothing else, no binaries is allowed. But of course you can encode binaries into text, for example, using algorithms like base64 or something similar, and this way transfer your binary over HTTP protocol in the form of very, very big text. So basically, web service is a black box, and the only thing you know about it is its API, so the set of procedures that you can call, and maybe the data structure that you can obtain from this web server, or you can pass to this web server. There are many types of APIs in use nowadays over the internet, but the most popular ones are SOAP and REST, and these are the two that we will be talking today about. Let's look at the difference between SOAP and REST. Basically, the difference between these two is the size and the transparency of this black box that I just told you about. So you can implement absolutely the same functionality using both of these. Basically, SOAP is a very big and a very black box. You never know what logic is behind it. This logic can be very different from system to system. You can guess what REST service does just looking at it. If, for example, your task is to provide others with the API from the ONCE Enterprise side, how do you select what to use, SOAP or REST? I like to answer this question like this. If this is some complex internal task, so it's a distributed system, but all nodes of this distributed system are yours. So they belong to you, you control them. Then in this case, probably SOAP is your best bet. If you want to provide some public access to your data, for anybody who just wants to look into a system, then you should use REST, because this way it will be much easier for your clients to connect to your service and to understand what it does and to use it. Let's start with the SOAP style services. So ONCE Enterprise supports bidirectional SOAP services, meaning that you can work with the third-party SOAP services, and you can also develop and publish your own SOAP service and make it public. And now let's see how it's done. So what I have here is two ONCE Enterprise applications. One is called Provider, and this one we will be using to implement our own web services and to publish them to outside world. And the second application, which is called Client, which we will use to connect to the first application to see the other side of the picture, to see how to implement it from the other side. So let's start with the provider, of course. This is where SOAP services live. I implemented simple example just to show you the idea, and it's called My Public SOAP Service. So first thing you will need to take into account implementing web services is called namespace. And namespace basically is a prefix for all the names you will be using inside of your service. The system is distributed. It lives in the internet, and of course it lives together with many other systems. If there are two procedures with the same name, you need a way to tell the difference between different services. And this namespace thing is just this difference. How it's done usually is you use your domain name, because your domain name is unique. This prefix will guarantee the uniqueness of all the names that you will be using after that. And in this case, I used my domain, lab.1ci.com. Next thing, your SOAP service should have procedures. In my case, I implemented the only procedure, and I called it my public procedure. So it doesn't do anything meaningful. It's just here to show you the concept. So this is how I add a new operation or new procedure, and this is how I add the parameters inside of the procedure. And this is an important part. This is where you specify the value type for the parameter. So the parameter has a value type. It has this checkbox, this flag that tells that this value can be omitted when you call this procedure. And this is a very interesting one. It tells which direction this parameter travels to. Then there is immutable parameter, which is both input and output, and it means that it might be changed by the server and you will get back the new value. And then it's another parameter which is output, so you cannot pass anything through this parameter, but the server you call will return some value inside of this parameter after the call is over. So this is how we defined the name of the procedure and its parameters. And now let's get to the implementation part. And implementation part lives here. So as you can see, there is a procedure name, and this is the 1C procedure. So I click here, and this is what my service does. And as you can see, the name of the function and the name of all the parameters are absolutely 1C native. So nothing weird, nothing unknown, nothing I've never seen before. It's just a function in terms of 1C enterprise and just parameters of this function. And this is what I do in this normal function. So first of all, this message that will be output to the caller, and I just describe what parameters were passed to me, and then I do this operation once again and just return 200. So let's talk about this 200. This 200 is so-called status code, and they are all standardized. Everybody knows what they mean, and there is a Wikipedia article about those codes, and I will post this link to the chat section in the Zoom. And basically there are 5 categories, and category 2 means success, and 200 means everything's just fine. And believe it or not, but this is it. The implementation part is over. Now I have the SOAP service, and the only thing left to do for me is to publish it to the web server. So this is of course done right here in the administration menu. When you publish your 1C Enterprise application to the web server, you have several options. You can publish your web client or thin client to allow people to connect using the 1C Enterprise client to the info base, which is controlled by this flag. Then you can decide whether you want or not to publish web services, SOAP services, which is controlled by those flags, and you can select individual services. And when it comes to the REST services, this is where you set up what to publish and what to not. And then I just click publish and it's done. And the name I gave to my publication is Integration Provider. So to call it from the browser, I need to do this. I need, of course, to specify the name of the server first, and then slash, and integration provider, and then the language code. And this is how I run the web client and connect it to the to this application. Now, how do I call the service published from this application? I add WS, which means web services, of course. And the name of the service I want to call now is, of course, my public SOAP service, so I can just copy it. I put WSDL, and this is what I get. This is my service. This is the best way to check if your server works, if the publication is valid. So before you start working with the SOAP service, try this. If this works, then everything is good. And now let's see how we can call this SOAP service from another ONE Enterprise application, which is called client. So first thing we need to do is we need to add a so-called WS reference. So this is our service that we just implemented, and this link here is exactly the same link I just showed you in the browser. So first of all, this is the content of the web service that we just called, and it contains this single procedure that is called my public procedure, and inside there are parameters. And again, I can see each parameter, what it does, whether it's input parameter or output or both, can it be empty or not, and stuff like that. So now I'm ready to start using this service, and this is how it's done. So what I did is I created this command form, and the first command is to call my public SOAP, and this is how the procedure looks like. This is how I call this service. So first of all, I take this WS reference and I create its proxy, this WS variable, and then I just call the procedure provided by this web service. It's called my public procedure, and I just pass those 4 parameters in there, and my number is set to 15 and message string is empty at this point. So let's try and run this simple code, and this is what we will see. I'm opening the integration test form, clicking this link, and this is the result. My number is incremented by 1, the result is 200, and this is the message that server returned me. One more interesting thing is the distributed systems debugging. And first of all, I need to make sure that my ONE Enterprise server is run with the -debug flag, -debug parameter. And the second thing I need to do is I go here, debug, attach for debugging. Then I click auto attach, and here I select web services. And now I can put a breakpoint here, call this server one more time. And as you can see, now I'm inside of the debugger, and it works absolutely the same for REST services, and the only difference is that you need to auto attach HTTP service. This web service also lives in the same provider, but now it's called sales. And the idea here is that I want to give access to my sales documents. So I create a new web service called sales. Again, same namespace, and different operation called export sales docs, no parameters, and here is my sales document, and it has tabular section with products and with the reference to the product catalog, and company refers to the company catalog, of course. So let's see how I implement this more realistic example of web service. So this is the procedure that will be called as soon as the service is called, and the level of difficulty here is higher because we have the entire data structure to return, and it needs to be somehow defined. And the way we do that is using the XDTO packages. And this is my XDTO package. So first of all, I have sales doc that describes a single sales doc, which has ID, date, number, company, and sales products. And sales products is a list, right? And the company is a reference to a different object, and this is this object. So I have company, again with ID, code, and description, and here I just refer to this object. And the sales products is a reference to another object called sales product, singular, and it lives here, and basically it describes one row of the tabular section. And this singular line is converted into the array, into the list, using these two parameters. So we have minimum number and maximum number. And what it means is it means that each parameter can be represented as a list, and by default it's set to 1 and 1. So minimum number of elements is 1 and maximum number is also 1, so this is a single element. But if I set these parameters like this, from 0 to -1, it will mean that this is the list with any number of parameters. So -1 basically means no limit, and 0 means that the list can be empty. And I also have this sales doc object, and I use it to return the list of sales docs. So this is my data structure that I will be working with. And now this is what I do. I select all sales documents with this simple code, and then cycle through those sales documents and add each sales document to the this XDTO package that I created here in these two first lines. So this is what I do here. I create this object of this type by asking XDTO factory to give me this type, and then creating again asking the XDTO factory to create the object of this type. So, and then I just add each document I read to this XDTO package, and then I just return this package. So this is a very simple piece of code, and not so simple piece of code lives here. So export sales doc. How do we export a single document to the XDTO? And this is how, again, I just ask XDTO factory to give me the sales doc type, then I create an XDTO object of this type, and this is my object. And then I just put attributes and fields from sales document into this XDTO object, and then I just return it. Okay, and so on. So basically this is what all this code is about. And again, the only thing I need to do after that is to save my application. I don't need to republish it. I already did it. I'm just saving it, and it's immediately accessible. I don't need to republish it every time. If I want to check if my publication works as it's supposed to, I can always do the same trick here. I just use the different procedure name and run this link, and this is my WSDL. And now we are back to the client application, and again same deal here. So I import the WSDL using the same link I just showed you, and once enterprise read this WSDL, and now shows me that there is one service with this export sales docs procedure, and shows me the data structure that this service provides. And basically this is my XDTO package that I just created on the provider side. So let's see how we call it. Again, creating the proxy object using the namespace and the name of the service and the name of the service version. Then just calling these proxies procedure by name, which is export sales docs. Let's see what it looks like. So I'm setting up a breakpoint and calling this service, and now here we're supposed to see the XDTO package with the data. So let's check it out. Okay, so here is our sales docs list. The list contains 2 records, and each record is its own XDTO object that I can open, and inside is the reference to another XDTO object, which is company, date, ID, number, and the list of products inside of each document. And again, we know quantity and price of the products, and we have reference to the product itself that we can open, and we will see that it's Pringles. Okay, so again, this all tree-like structure inside of one big object is all ours. We can start unpacking it and doing with this data whatever we want. So this was a more realistic example of what can be done using the SOAP services. And now let's get to the REST services. And again, different format, but the same deal. Bidirectional, simple, very easy to understand, very transparent. And again, once enterprise supports working with somebody else's REST service or implementing and publishing your own service, so somebody else can call it and do something with your data that you allow them to do. And now let's see how it's done using one's enterprise. So again, I'm inside the provider application, and REST services are called HTTP services in one's enterprise terms. So this is where they live, and I already added one service that is called sales docs. So the idea is that I will return the same list of sales documents, but now using HTTP service rather than web service, which is SOAP service, of course. And this is what we need to specify for the REST service with one's enterprise. First of all, we need to tell what root URL we will be using. And root URL basically means that these are the resources that you give access to. So root URL needs to be meaningful for somebody who is using your service. And it's basically an endpoint that gives access to some piece of data, and it's usually named after this piece of data. And this REST service, this HTTP service, provides access to sales documents, so naturally the root URL has to be sales. And second important part of the HTTP service world is so-called templates. So basically the service starts with sales, and then you can divide it into smaller pieces, providing different types of access. For example, I created 2 URL templates. One of them is called document, and it's supposed to give you access to a single document, and the second one is called list, so it's supposed to give you an access to the list. But here you have more flexibility, and you can come up with something of your own. And then on the next level we have the name of the HTTP method, and this is an important concept, and let me show you in more detail what does it mean. So this is a Wikipedia page on the HTTP protocol, and methods are a part of this protocol. So the entire internet built using the same protocol, and we are going to use the same methods everybody else do. And here is where these methods live. And the main point here is that this list of methods is predefined, and everybody uses the same methods, and no other methods can be used, unlike the SOAP, where you can create whatever method you want, name it however you want, and then you just publish this API, and everybody will use this method that never existed before. In case of REST services, this is not the case. The list of methods is predefined, and you use the same methods as everybody else. And here in 1C Enterprise HTTP service, this is where I select the name of the method I can use, and as you can see, they all are predefined. And there are a lot of them, and you won't use most of them probably, but there is several most commonly used ones, and get is the most popular. It basically means get whatever this service provides you with. So in this case, it's a sales documents list, get, so you will get the list of sales documents. Put usually means update some piece of information. So if document has put method, it will mean that I want to update this document. What else? Post usually means add something new. So again, for a single document, if I'm calling post method, it usually means that I'm adding a new document. Delete, obviously I'm deleting something. And then some marginal stuff that I never used in my life, and I don't believe you will be using as well. So, and here I implemented the get method, and this is the procedure that that does this get document list functionality. And this is what I do here. So first of all, I create a new HTTP response object, and it's very simple, and I give it the status code 200 at the beginning, which means that everything's fine. And then I export all my sales document into the JSON format, and then I just add this JSON into the body of my response. So I just put it into the body of my response and I return it, and this is it. And this is how I convert my sales document to JSON. So what I could do is I could create the JSON writer and then cycle through the sales document and write each of documents inside of this JSON attribute by attribute, field by field, filling up this JSON writer. So it's absolutely doable, but instead I used the object called XDTO serializer. So I create this new serializer, and then I open the JSON writer, and I tell the JSON writer that I will start writing an array. Then I select all documents, cycle through them, and get in the object. So sales doc is the current sales document object that sits in my memory, and then I just pass this sales doc to the serializer, and it converts it into JSON and it writes it into the JSON writer. Then I tell JSON that my array has ended and it needs to be closed. Then I close the JSON writer, and then I just return this JSON to the caller. And now let's see how I implement the call of this HTTP method from the client side. But before that, let's again try to call this HTTP service from the browser and see how it works. So we are doing basically the same thing we did here when we called the web service sales, right? And we made sure that the service is up and running and returns us the WSDL notation. And we can do the same with the HTTP service. And this part stays the same because this is again the same server, the same info base, right? The same language code. And here is where difference starts. So first of all, we use HS instead of WS, so HTTP service rather than web service. And then we specify the name of the service and then the name of the method inside of this service, right? And when we run it, this is what we get. So this is JSON, and this JSON contains those two documents that we have in our info base. And this is what we do on the caller side. First of all, we need to open an HTTP connection between our application and the service provider. So we open it like this. This is the connection between two computers. We establish it, and then we can use it many times to run many different requests and call many different services. So this is why it's a separate object. Of course, we do it over the secure channel, over the HTTPS protocol. So we use 443 port number, and we also create OpenSSL secure connection here. So it's how you always do it when you want to open a secure connection with somebody. And then we create the second object that is called HTTP request. And this request does not contain this part. So it does not know which server it goes to. It knows only the later part of the link, the name of the application, and all the rest of the link. So this is what you specify here, right? And then this is how we run this request. So we tell the HTTP connection that we want to run the method get over this HTTP request, and this is where the response will return into this object. And let's see what it will look like at the runtime. So this is how I call it. And to get the payload of this response, we need to call this method get body as a string. So this is how we get the response, and we return it in the form of message. And this is our string. So this is our JSON that we obtained from the provider side. And again, we can deserialize this JSON and start working with it, start making some sense of it, making some documents out of it, or whatever we want. So these were web services and how to implement them using one's enterprise. And now let's look at another aspect of this problem, of this picture. Let's say we want to call somebody else's API. For example, I have a Gmail account and I want to read my emails from my Gmail account and then do something with them. Of course, Google provides public API to access my Gmails if I need to read them into my application or something like that. And of course, this API is not open in a sense that I need to obtain some access before I will be able to read my emails. I need to confirm that I am who I say I am. I need to provide some credentials, and only after that Google will give me access to my emails. So when it comes to talking to other services implemented by companies like Google, etc., it's always about two things. First of all, most often you will have to deal with a thing that is called authorization, and also sometimes you will be dealing with another thing that is called authentication. And they both start with the same 4 letters, but they are different and they are about different things. So let's talk about it a little bit. You can think about authorization as a door key. So somebody, it might be not your apartment, okay? It might be somebody else's apartment. And this somebody else gave you the key to his apartment. And now you can take this key, open the door, and come inside. So this is authorization. Basically, you have something that authorizes you to perform some actions. Open the door and everything that comes after it. Authentication is a different thing. You can think about authentication as a passport. So authentication confirms that you are who you say you are, that you have this name and this age and this nationality and stuff like that. So when you arrive to another country and you go through passport control, you give your passport to the officer, and he looks at your picture and makes decision whether you are who you say you are, and whether you can enter the country or not. So these are two different things. They are somehow connected, but they are not the same. And we use key, somebody else's key in one scenarios, in one use cases, and we use passport in very different scenarios. So let's talk about these two different scenarios. When it comes to authorization, the problem is this. Let's say you want to access your Google account, right? So naturally your key is your login name and your password. So this is like the most natural choice for your key. But the problem is you cannot give your password to anyone. And sometimes you have to, and even nowadays there are still services that require you to provide them with your login and password, especially when you, for example, connect to your bank account. Bank applications that collect your information from bank and then show it to you, they often require you to give them your access to the bank, which is obviously not secure. Anything that requires you to give your password in open form to somebody is not secure, never. It is not how it's supposed to work. And first of all, it will be passed from your browser through public Wi-Fi or something like that. And anybody can intercept this transfer, and even if it's done over HTTPS, it's still not completely safe. So OAuth basically aimed at resolving this issue, giving you access without you giving your password to anyone. And this is how it works. So this is OAuth has many different workflows, and one of the most common ones are called authorization code workflow, and this is what you can see here on the slide, and this is how it works. So first of all, your client's application, which is something you implement, and you want to get access to, for example, Gmail, right, or some other third-party APIs. This application requests the authorization from Gmail or from some other provider that has this information. So authorization can be implemented in many different ways. There are different protocols. For example, SAML is another protocol that does the same, but the most modern one and the most widely used one is OAuth 2.0, and this is what we will be looking at. And the advantage of this protocol is that it works anywhere in the web, including mobile devices, including IoT devices like smart fridges and smart irons and stuff like that. So it works regardless of what kind of platform you're at, unlike SAML that works mostly with computers and with browsers and stuff like that. So it's more traditional internet. So OAuth has many different workflows, and one of the main ones that we will be using is called authorization code workflow, and this is this workflow on the picture on the slide. So let's say you build an application here to the left, client's application that wants to get your Gmail access and read your emails from your Gmail account. So Gmail account is to the right, the blue one, and this is how it works. Your client's application requests authorization from the Gmail, and what Gmail does, it directly talks to your user that is using your client's application. So it doesn't talk to your application, it talks to the user directly, which means that it directly opens the separate browser window on its own domain somewhere inside Gmail, and it asks user to provide login and password to make sure that this is the owner of this data and he has right to access them. And after this login and password is provided, Gmail again asks directly to a user if user consent to give access to this information. And when user says, yes, I confirm that I allow this access, then Gmail sends authorization code. So it's not this code doesn't give you any access, but it's a first step on your way to the access. And this code is given you not through the browser or through some other front channels. It's given you through the back channel. So Google server talks to your server, and Google server passes you this code like under the table, not through browser, but server to server, which is much more secure, right? So it talks directly to your server. It passes you the authorization code. Then you use this code and you request access token using this code. Gmail compares the code that you provided with the code that it has, makes sure that it's a valid request, and gives you an access token. And then using this access token, you can access data. In this case, your emails in your Gmail account. And here is an official link to the OAuth documentation that again I will send you to the chat as soon as this presentation is over. So it explains the same workflow that I just explained. And the important thing about this workflow is that OAuth is done over HTTP requests. So OAuth is an HTTP API built on top of the HTTP, and basically use the same technique that we just used to work with the REST services, but requests and responses just look differently. That's it. Of course, the first thing that we need to do is to set up the Google account that will allow us to talk to Google services. So Google needs to know who we are, so it can give us the adequate access to resources that belong to us. And this is done through Google Cloud Console, which you can see right here. So you need an account in Google Cloud in order for this to work. And I just created one. This is how the console looks. And this is OAuth client IDs. So this is where you register all applications that will ever want to talk to different Google APIs. And I registered the only one single application that I call web client. And this is what's inside of these settings. Its name, it can be anything that you want. And as soon as I register my application in Google, it gives me two very important things, two preliminaries, two keys that I will use down the road talking to Google. And first key is called client ID, and as you can see, it's just some meaningless string. And the second one is called client secret, and it's again just some gibberish. And these client ID and client secret belong to this application, so they are specific to to each application. And besides that, I will need to say that this URI, this is linked to my server, and this server is allowed to run some actions on Google Cloud, use those APIs. And I also need to specify the redirect URIs, which I will talk about a little bit later. So now the important thing is that I need to register my application, and I need to get client ID and client secret from Google. Now, I don't need the provider application anymore because in this case, Google is my provider. It's not my application, it's somebody else's. So this entire functionality will be implemented inside of the client application right here. Now, inside of this application, I created two constants, client ID and client secret, to store the values of these two keys I got from Google. And I also have a form, some interface to specify those values. So this is client ID that I copied from the browser, and this is a client secret. And these two tokens I will obtain from Google later, at the later stages of this implementation. So these ones I don't know, and I need to ask Google to provide me with them. And this is how I do it. So first thing I need to do is I need to send this request. So as soon as user clicks the login link, or it's not even a login link, just a link to get the information that I want. So I'm sitting inside my application and I click get my emails from Gmail. So this is what I click. And after that, my application has to send these authorization code requests, has to request the authorization code from Google. And the question is, what kind of request is this? So this is the request, and create this long link, and then I just open it by running the application. So I just tell Once Enterprise run the application based on this link. At what Once Enterprise does at this point, it looks at the link, it's a web link, so it just opens the default browser and passes this link to the default browser. And this is what the link contains. So first of all, I talk to this endpoint. This is where Google accepts OAuth requests at. Response type. This is where I tell the Google OAuth API what I want. And what I want is authorization code. So first I want a code. And then I will exchange this code for authorization token. But first I need a code. So I request this code. I pass my client ID that I read from my constant. And then this is very important and very, very tricky stuff. In this parameter that is called redirect URI, I tell Google where my service lives, that Google has to call to pass the authorization code to. So this is my server. I need to publish it, and I need to give its URL to Google. So after Google creates authorization code for me, it will send this code to this service that I specified in this redirect URI. And again, it's all sent over the back channel, so server to server. So what I need to do before I can send this code request is I need to implement this service on my side. And this is this server of service on my side. So it's client application, and here in my client application I implement this service: root URI authorization, endpoint OAuth code, and method get. So this is what I want Google to call to pass me the code. So I implement this service, and we will get to it later. And then I pass a link to this service to Google. What other parameters we have here? And here I ask Google to ask for consent. So I don't want him to trust that this user gives me access. I want to ask him explicitly about the consent. And this is the parameter called scope. Basically, it's what kind of data I want to access, because this endpoint can contain many different types of data, and I might want some of them, or I might want to read them, but won't be able to change anything. So this is what is called scope. And here I just say that I want everything. So I want the complete access to my entire Gmail system. Okay, so this is my request. As I said, it will be just opened here. It will be just opened here in the outside browser, and this is what it will look like. So this is what will happen after I execute this. So this is what happened. As soon as I open this link in the external browser, Google asks
me if I'm the one who I say I am, and if I consent, if I agree to give somebody access to my Gmail. And it says that OneCI.com asks for permission to access my data, and I created this Gmail account specifically for this exercise, so it's a separate account, and this is what happened. And now, as soon as I confirm that yes, I agree, and I allow this application to continue getting access, after that, what will Google do is it will call this service that I published and will pass the authorization code to this service. So let's see what's inside of this service and how is this implemented. So this is probably the most tricky part of the entire exercise. And let's just do this. So let's debug it step by step so we can see what's going on here. I am telling the platform to attach all HTTP requests to this application, and let's do it again. So again, authorization form that Google shows to me. I'm agreeing with everything. It says that OneCI.com already has some access, but now it requests to authorize it second time, so okay, agree to that. And now Gmail send us request to our HTTP service, and this is what's going on here. So first of all, the request contains query options, and one of those options is base URL, query options, fixed map, and one of those options is called code, and this is our code. So this is the secret code that Google sent us, so we can use it to exchange for the authorization token. So we send this request. Google opened the authorization prompt. I gave my consent. This is the arrow number 4. Google passed the authorization code back to my server using the HTTP service that I published, and now I want to use this code to send another request from my server to Google server to get the access token, the authorization token. And this is how I do this. So I have access code. I also read the client ID and client secret from my constants, and then I combine. Then I put together another request. This time the grant type is authorization code. The parameter grant type is authorization code. I pass client ID. I pass client secret, and I pass the code that I just obtained from Google. And this redirect URI is again points at the same server, so at myself basically. But this time Google won't send me a separate request. It will just answer to my request and give me the authorization code. So let's see what happens. I use again HTTP connection to Google using SSL secure connection, so over HTTPS. I add this map to the header of my request. This is a Google requirement that can be found on the documentation. So this is what I do. Again, this is the endpoint where the access token live. So I go here and I create this request. Then I pass query parameters from this big string into the request, and then I send it to Google. So I send this request to Google, and now Google answers me. And status code of the answer is 200, which is good, which means everything's works smoothly, and my code is confirmed, and now I should get the access token. Now I get response string again using getBody as a string from the HTTP response object. I use JSON reader to decipher this response, because this response string is JSON. And let's see what's inside of this JSON. So here you go. So here you go. This is access token, and this is the token itself, the token value. This is the lifetime of the token in seconds. So basically this token is valid for 1 hour, and after 1 hour it will expire. I won't be able to use it after this amount of time, but I can get a new access token using the refresh token. So I have 2 tokens, one to access data and the second one to refresh my first token in case it expires. So these are 2 main pieces of information I get from Google: access token and refresh token. And of course I use JSON reader to read this response. Here my access token, here is expiration date, and I just save those tokens to constants right here, and this is it. And I also read the refresh token and also save it to the constants, and this is it. So basically by this time my application is authorized to access Gmail data, and here is how I access those data. So I just call Gmail, another Gmail API that gives me access to the emails directly to the emails, and here is my email. So let's see how they look. So this is my Gmail account that I created specifically for this summit, and there are some test emails that I sent to myself and stuff like that. And these are the same emails I just read using Once Enterprise from my Gmail account. So let me show you how this worked. This is show emails procedure, and what this procedure does, it calls different API that lives here, Gmail Google APIs.com. It's completely different site, completely different server probably, and this API that gives me access to Gmail requires access token. So when I send any request to this API, it checks my access token, compares it to the access token that was issued by the OAuth part of Google ecosystem, and if tokens are equal, if tokens are the same, if my token is valid, then it gives me access to all my emails, and this is how it's implemented. So this is where I get my emails from, and this is the first parameter, access token, that I pass in this request, and that's basically it. Then I get body as a string from this response, from the response of the Google, and there are IDs. First there are IDs of all my emails, and then this is what happens. Let me show you in Debugger. So This API gives me this data, returns me this data. As you can see, array of messages. So I'm opening this array, and basically it contains only IDs of all separate messages. So first level API gives me IDs of my emails, and then using those IDs I can get information about those emails, and this is exactly what I do here in this cycle. So I just go through those ID and request the subject of each email that is in this list. And again, this is just how Google implemented it, and this was not the point of the exercise. The point was that talking to this API requires me to provide access token, which I get through OAuth, and OAuth part is the most important and the most difficult one. And now to our last topic for today, which is authentication. And again, authentication is your passport, is when you confirm that you are who you claim you are. And the purpose of this confirmation is that you might want to delegate to someone your authentication, so it can give tell everybody else who asks that you are who you say you are. For example, you can use it for a single sign-on. It's when you have a single account, for example, in Google or in Facebook, and then you use this single account to connect to all kinds of different services, and you don't have your separate accounts on each of those services. You just use your single Facebook account, and whenever you connect to some other service, this service asks Facebook if you are who you say you are, and lets you in. Facebook confirms it, and then the server lets you in. So this can be used for single sign-on or for persistent sign-in. It's when you log in once, and then you have a kind of certificate that lives somewhere in cookies, and when you go to the same service second time, it doesn't ask you for the password, it just lets you in because you already logged in, for example, yesterday. And it lets you in for some time, but then your authentication expires, and you're required to provide the service with the login and password one more time. And the way it's done nowadays is called, the protocol that supports this workflow is called OpenID Connect, and it's different from OpenID that was long before, and it was one of the first protocols in this area, and it's supported by 1C Enterprise, but this is a different protocol. So OpenID Connect is not the same as just OpenID. And basically OpenID Connect is some extension of OAuth protocol, so it's now just a part of OAuth protocol. And 1C Enterprise does not support bidirectional OpenID Connect workflows, so you cannot use 1C Enterprise to build identity provider that everybody else can use. But you can use OpenID as a way of logging your users into the 1C Enterprise application. For example, if you have a web application and somebody has account in Google, it can use this Google account to connect to your 1C Enterprise web application. So it works basically the same as, for example, operating system authentication, when you use your Windows login and password to connect to your 1C Enterprise application. So let's see what we have in this department. First of all, let's see how it works from the user's perspective. So I published my integration client application to the web, and I enabled OpenID Connect authentication, and now when I log into the system, this is what's going on. So all of a sudden Google sign-in page is opened, and I'm now somewhere on the Google domain, and I can select, for example, this user, and as soon as I do, I again back to my lab.1ci.com domain, and I'm inside of my application. So what just happened, I authenticate myself using Google as an identity provider, and Google told Once Enterprise that I am who I say I am, and Once Enterprise let me in, logged me into the application. And now let's see how it's implemented. So I'm back in my client application, and I have a single role here called admin, and I have several users. I have admin, just a normal user, and I also have this guy whose name is exactly the same as my Gmail address. So this is important. This name should be the same as your name in the identity provider that you use. In this case, it's Gmail. And the second important thing is this flag. So I turned on this flag, OpenID Connect Authentication, and basically it does the same as this OS authentication, but in this case it's not OS, it's some identity provider that lives somewhere in the internet, but it does the same. It makes sure that I am this user, and then tells Once Enterprise that this is true, this is all good, and Once Enterprise lets me in. So this is the first thing. I need to have the same name here, and I need to have this flag turned on. The second thing I need is this very weirdly looking piece of code inside of VRD file. So VRD file, it's basically what Once Enterprise create whenever you publish your application to web server. So it creates VRD file, and inside of this file you have your infobase parameters and stuff like that. And for example, you have your HTTP services published here, and there is also a section called OpenID Connect. And here you need to specify some links to very specific endpoints inside of each identity provider. And you need to specify the redirect URI that points inside of your application to auth form.html. So this auth form.html is actually like some part of your application that platform publishes automatically for you, and that interacts with the identity provider, Google in this case. And basically this is it. So the important question is how to write this code, and there is no simple answer to that, and we have some resources that explain how you need to set it up for each identity provider, for several different identity providers. But basically you need to follow the example, and the best way is just know this piece of code and just copy it into your VRD file, and it will work. Or we have some Russian articles and Russian data processors that help to set this up, but unfortunately they are not translated to English yet, and we will be thinking about the translation. And if you are interested, if it's something that you will need, please let us know, and we will help you, or we will translate those documents and those data processors for you. So this was OpenID Connect for you, and not really anything else I can tell about it. So Once Enterprise supports it as a client of OpenID Connect protocol, but does not support it as a provider of identity that other services can use. And one more important thing about setting up the publications for this kind of stuff. So as soon as we added roles and users to our client application, there is one problem. And the problem is that the auth workflow now won't work the way it was. So when Gmail sends us authorization code, it calls our HTTP service. And as long as we have no users in this application, the HTTP service is open and anybody can call it. But we added users, and now all of a sudden this HTTP service requires Google to know name and password to access it, which is obviously not a good thing. So we cannot tell Google what password and login to use to access our HTTP service. So what we do instead is we publish the same application twice. So this is the first publication. As you can see, it points at integration client application, okay, and this is like the normal application that gives you access to web client, to thin client and stuff like that, that supports Google OIDC provider. So it's like the normal way to enter the application. But we have the separate publication for the same application, and this is where it lives. And this one does not allow you to access the application itself, but it publishes HTTP services. And the way it does it, it contains the name of the user inside of this IB parameter. So admin doesn't have passwords in my case, but if it did, there would be a password parameter and I would specify it in this file. And this is much more secure than giving this password to Google and making him call our HTTP services using username and password, because this file just sits on my computer on my server, and nobody, it's very hard to, if my security is okay, it's very hard to get access to this file. So this way we publish like one normal publication, and the second one only for HTTP services and anonymous one. So it contains username and password inside of the publication itself, so anybody can access this HTTP service without providing the login and password. And one last thing I wanted to show you today is those authorized to redirect URIs. So the way Google does it, it asks me to provide it with all redirect URIs that I will use in my application, so it could compare them and make sure nobody tries to redirect it somewhere to some malicious site and to somewhere it doesn't want to go. So all URIs that I use in my requests to Google in parameter redirect URI, I need to register with Google, and this way it knows that they are safe, and it can use it to pass some sensitive information to those URIs, like authorization code, for example, which is obviously sensitive information. And I can imagine that's a lot to digest, of course, especially if you have no previous experience in this field. But again, we will publish this video, we will publish links to both client and provider applications, so you can look at them. And right now I will be able to answer all your questions if you have any. So thank you very much, and yeah, good luck with building distributed systems with ONE Enterprise.